Hello students, welcome to IMS Academy Gate Score Booster session on communication system subject. This is the second session regarding communication system subject. Yesterday we have done the first session. In that session we have discussed regarding the first 3 chapters related. We have discussed 20 questions. Okay, whoever missed that session, so kindly watch that particular session in your free time. In this particular session we are going to discuss once again 20 more questions related to the last 4 chapters of communication system subject. Okay, this subject is common for 2 branches, EC and instrumentation. All of you kindly like and share this video link with maximum number of your friends so that every student can get maximum benefit by participating in this particular live session. Okay, and whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel and then click on the bell icon so that you will be getting all the instant notifications. You won't miss even single video. Okay, right. I hope all of you quickly like and share this video link with maximum number of students, maximum number of your friends as much as possible. Okay, right. So this is the first question regarding in this particular session with respect to the previous session. This is the continuation number. In the yesterday, as I mentioned, yesterday session we have discussed 20 questions. Now this is the 21st question. Okay. So for every question I will be giving some time. All of you can give a try and you can check your confidence regarding communication system subject. Yeah, good evening Mathan. Yeah, very good evening one and all. Yeah, first of all read the question. Here in this question you are having one random process y of t equal to 3x of t plus 2. Okay, and regarding x of t they have mentioned here x of t is 0 mean stationary process. That means the mean value of the random process x of t is 0. Okay, right. Then having autocorrelation function with respect to x of t, random process autocorrelation function given, that is 5 into e power minus 2 mod tau. Yeah, good evening Gopal. Right. Here in this question you are supposed to calculate power of y of t. So power of the random process y of t. I hope all of you know how to find the power of any particular random process. Here see, when you are having the deterministic signal, how to calculate the power, that we have already covered in the yesterday session. Now whenever you are having random signal or random process, that time we are using the concept of expectation. Okay, so here power of y of t, that is nothing but, okay, just for reference here I am mentioning power of y of t is equal to expectation of y of t. expectation of y of t. Sorry, expectation of y square of t. Expectation of y square of t. Now here y of t is nothing but what? 3x of t plus 2. Now this one you can substitute here. Expectation of, in place of y of t, this entire equation, 3x of t, 3x of t plus 2 whole square. Okay. Now you are getting a plus b whole square format, you can expand it. A square, that is, directly I am writing 9x square of t plus b square, that means 2 square, that is 4, plus 2ab, 2 2s are 4 into 3, that is 12x of t. A square plus b square plus 2ab. Yes, very good Harshit, very good, excellent, excellent. So here we have expanded by using a plus b whole square formula, right? Now after this, here for this overall equation we have to perform the expectation. So while you are writing expectation operator, say for example expectation of x, that is nothing but integral minus infinity to infinity x into fx of x dx. Okay, like that, suppose if you are having expectation of x plus y, so integral minus infinity to infinity x plus y into the corresponding density function you are getting, right? So that means here, since you are performing integration, I hope all of you familiar, whenever you are having integration of suppose multiple terms summed together, that time you can perform integration with respect to each and every term. After that you can perform algebraic sum. So that means x, since just like integral operator is a linear operator, okay, in the similar way expectation operator is also a linear operator. That means you can perform expectation with respect to each and every term. After that you can perform algebraic sum. Okay, right. So here we can write this one like this: expectation of 9x square of t plus expectation of 4 plus expectation of 12 into x of t. Okay, right. I hope all of you know the properties with respect to expectation, just like normal integration. From there also you will be getting. Okay. See, whenever you are performing integration, suppose you are having like 4x dx. So 4 is a constant, we can keep outside. Like that, here expectation of 9x square of t, it is same as 9 into expectation of x square of t. 9 into expectation of x square of t. Okay, here expectation of constant is nothing but constant only. Say for example, expectation of when you are performing integration of constant. Okay, so definitely from that integration after doing, definitely you will be getting that constant only outside. Like that, here expectation of, because here integral minus infinity to infinity x into fx of x dx, here x is nothing but 4, that we can keep outside. Okay, so whenever you are performing integration of probability density function from minus infinity to infinity, that is nothing but area under the probability density function, that is nothing but sum of all the probabilities, that is nothing but 1. So accordingly you are getting that part a constant. I hope all of you got to know how we are able to say expectation of constant is nothing but constant. So here we are getting 4. Okay, then here just like here we can write this one as 12 into expectation of x of t. 12 into expectation of x of t. So here in this question, if you observe, already we are having one data. X of t is 0 mean stationary process. That means the mean value of x of t is nothing but 0. So since expectation of x of t is 0, right? So this overall value is going to be 0. Okay. When you are adding 0 to anything, resultant answer will remain same. There won't be any change. Okay. Now here you are having expectation of x square of t. This one we can write it as expectation of x of t into x of t. Okay, for one question I am discussing completely, but similar question if you are getting directly in one step I will discuss. Okay, So here 4 I am keeping as it is, and 0 when you are adding, resultant answer will remain same. Now whatever the expression here we are having, I am representing further like this, x of t into, this term I am writing either t plus 0 or t minus 0, your wish. In any order you can write. So that means when you observe this expression, expectation of x of t into x of t plus tau or x of t into x of t minus tau. Okay, so this particular function is nothing but autocorrelation function at tau equal to 0. So 9 into Rx of 0 plus 4. See here it is very simple. Whenever in the given question regarding the random process, if they have given the density function, that time regarding expectation operator, what is the standard definition we are having, accordingly we can use that formula, we can find out. But whenever in the question, if they are not given the density function, rather if they are giving autocorrelation function, that time you can use with respect to autocorrelation function basic property. Okay, suppose here for generalized case if you are having tau, then you can write this expression as Rx of tau. But here in this case tau value is 0, that's all. Now you can observe here in this function in place of tau you can put 0. So if you are putting 0, e power 0 is nothing but 1 into 5 is nothing but 5, right? So that means here you are getting 9 into 5 plus 4. 9 5s are 45 plus 4, that is nothing but 49. So since in the question they are asking power units are watts, 49 watts. So answer for this question is 49. I hope it is clear for everyone regarding this question. So for all the students who were not enrolled at our IMS GATE Academy for any of the program, but whoever targeting for GATE 25 exam, so for all those students I am strongly recommending for those students to enroll for test series plus program at our IMS GATE Academy regarding the Google form already provided in the description of this particular video. Okay, see whatever the questions we are discussing in our series of GATE score booster sessions, I hope all of you come to know the quality of the questions that we are covering and the kind of confidence that you are getting from this series of lectures. Like that, you can do good number of questions you can attempt through our test series. Okay, we are having like chapter level test we are having, and then subject level test like basic subject test, advanced subject test, and even multi subject test we are having. After that you are having full length mock tests all. Okay, so whatever the limited time you are having before your GATE exam, the more number of tests you can attempt, so that you can check each and every, with respect to every subject you can check whether regarding that particular concept or regarding that particular chapter, whether you are good at, whether you are able to perform very well, or whether you have to prepare, or whether you have to revise something else. Okay, yet to prepare something is there, or whether your preparation is up to level or not, you can cross check. And one more thing also you can cross check regarding time management, and you can identify wherever you are doing a silly mistake, or whenever some tough question is coming, how you are tackling. Okay, so all the strategies, everything, time management and exam atmosphere also you are able to get if you are attempting our test series. Okay, and in addition to that we are providing last 33 years GATE question booklets along with here GATE questions along with the detailed solutions. Okay, with respect to technical subject you are getting, and with respect to maths and GA you are getting with respect to 6 branches: EC, electrical, instrumentation, computer science, mechanical, civil. Okay, so you are getting the benefit of all this if you are able to enroll for test series plus program, and of course you are having all other benefits as well. Okay, whoever like want to get very good marks in the upcoming GATE exam, okay, so for all those students you can enroll for test series plus program because as early as possible, because this particular 20% offer is running currently for limited time. Okay, right. And one more important update, whoever currently in second year BTech or third year BTech and whoever want to write the GATE exam in the upcoming years, for them I am recommending to enroll for live online program at our IMS GATE Academy. So all these are the features regarding live online program. You can book any of the free you can book the free counseling session regarding the link already provided in the description of this particular video. Our counselors will discuss in detail about our live online program. Okay. Yeah. Now we'll see the next question. All of you give it a try. Here, okay, first of all you can mention one note point here. You are having random process x of t regarding that autocorrelation function. You are having like this. Okay. And here For x of t, you have to find out the variance, and here in this question, you can consider one note point. Expectation of x of t is 0. Just like earlier question, you can consider expectation of x of t is 0. Okay, now all of you give it. In this question, you have to find out the variance. For solving the questions of random process, the random variables is the prerequisite. So regarding random variables, you might have studied in the mathematics subject in your maths. So whatever the formulas you have learned regarding random variables, just you can go through the basic formulas whichever important for solving the questions of random process. It is simple question only. I hope all of you can give it a try. I hope all of you can get the correct answer for this question. It is direct question. Yeah, just observe here for solving this question, if you know the variance formula, then only you can solve. It is very simple. Variance of x of t, variance of x of t variance of x of t equal to m2 minus m1 square. Okay, first I am writing generalized case, after that I am representing the short. Okay, so you are having expectation of x square of t minus expectation of x of t whole square. Expectation of x of t whole square. Okay, in other words, I can say expectation of x square, that is nothing but m2. Next, expectation of x of t, that is nothing but expectation of random process, that is the first order mean. Okay, so you can consider m1 and square of that. So variance is nothing but m2 minus m1 square. And in this question, already we have mentioned one note point regarding x of t, mean value is 0. That means m1 is 0, so square of 0, definitely it is square 0. So you are getting m2 minus 0. So from here you are getting m2, that's all. See, in the earlier question, you are having x of t, one random process. After that, you are having one more random process y of t in terms of x of t. Okay, and for y of t, we have calculated the power. Okay, so in general, power of any random process or any signal, that is nothing but expectation of that particular random process square. Okay, but in this question, the twist is what? Instead of asking power, they have asked variance. But here, because of this note point, expectation of x of t is 0. So whenever expectation of x of t is 0, variance of that random process is same as expectation of x square of t. Okay, for the same question, say for example, if they ask you to calculate power of x of t is same as variance of x of t for this question, I mean to say. Okay, so that means it is very simple. Here variance of x of t is nothing but m2, that is nothing but expectation of x square of t. Okay, so when you are getting expectation of x square of t, just you can observe expectation of x square of t, that one we have written like this. After that we have written like this. Then what we have mentioned, autocorrelation function at tau equal 0, that's all. Okay, only for understanding purpose in this question I have given complete description. Once if you know this basic property regarding autocorrelation function, now from now onwards whenever you are solving like this questions, no need to expand, directly in one step you can write autocorrelation function at tau equal 0, that's all. Okay, right. Yeah, so m2 is nothing but expectation of x square of t, so that is nothing but autocorrelation function Rx of tau when tau equal to 0. Okay, so here in this question autocorrelation function you are having like this. Here wherever you are having tau you can substitute 0. So from here what you are getting, so 27 into 0, that is 0 plus 3 divided by 3 into 0 square, 0 plus 1. So that means you are getting 3 by 1, that is nothing but 3. Okay, so here in this question variance we have asked, that variance is same as power of the random process x of t. Okay, all are same, that is 3. Okay, right. Next question, all of you give it right. This is an interesting question. I am giving 2 minutes time, all of you give it right. Okay, first I am discussing what we have given in the question data, and accordingly by considering that hint point you can give it right. Okay, I have paused the timer. If a white noise with power spectral density of 10 power minus 6 watt per hertz, okay, is applied to a system with impulse response h of t. So you are having one LTI system. For that input power spectral density is 10 power minus 6 watt per hertz, and regarding that LTI system impulse response is h of t equal to e power minus 2t 4t. Okay, e power minus 2t, here it is u of t, sorry, e power minus 2t u of t. Okay, if output of the system is y of t, then expectation of y square of t. Okay, regarding that particular LTI system, at the output you are getting y of t. For that signal you have to calculate expectation of y square of t. Okay, now all of you can give it right. Yeah, Nobita, you can consider by default it is a double side. Okay, unless otherwise, if it is a single side, okay, they will mention the question. Okay. Right. So here I hope all of you know one important relation with respect to you are having one LTI system. Okay. So output power spectral density. First of all, you can write this one important note point. Output power spectral density equal to output power spectral density. Okay. In other way, I am writing like this. Output power spectral density equal to input power spectral density into magnitude of transfer function whole square. Output power spectral density equal to input power spectral density into magnitude of transfer function square. But in this question they are asking expectation of y square of t, that is nothing but power of y of t, power of y of t. Okay, here you are having power spectral density. If you perform integration of the power spectral density, from there you will be getting power. Okay, that is a hint point for this question. Yes, very good, Nobita, very good. So here in this question we have to find out expectation of y square of t, that is nothing but integration of power spectral density. Okay, right. First of all, let us calculate. Okay, just for reference I am putting that another point also, expectation of y square of t, that is nothing but integration of power spectral density. Okay, here output power spectral density I am considering as Sy of f df. Okay, here integration with respect to frequency. Okay, right. So now you can find out first of all here regarding output power spectral density. Okay, so here you are having h of t equal to e power minus 2t u of t. Okay, I hope all of you know how to apply Laplace transform for this particular signal. So here you will be getting h of s equal to e power minus at is nothing but 1 by s plus a, 1 by s plus a, right. So now here you can substitute in place of s j omega. Okay, so here in short I am writing that one only like in terms of f. Okay, 1 by s plus you can put j omega, after that omega is nothing but 2 pi f. Okay, now here you are getting on the right hand side in function of frequency, that's why here we have mentioned h of f. Now for this signal, for this particular transfer function h of f, you have to find out the magnitude and then you have to perform square. Magnitude of h of f is nothing but, here numerator you are having 1, magnitude of 1 is same 1. Then denominator you are having a plus jb format, so for that magnitude is square root of a square plus b square. So here real part is 2 square plus imaginary part you are having 2 pi f whole square. 2 pi f whole square, right. Now this particular magnitude you are having 1 by square root of, and here we have to consider magnitude square. So that means here square root and square both will get cancelled. From here you are getting magnitude of h of f whole square, that is nothing but 1 by 2 square is 4 plus, here also I am performing square, 2 square is 4, then pi square f square, pi square f square. Okay, right. Now here you can observe output power spectral density is input power spectral density into magnitude of transfer function square, right. Sy of f equal to, here input power spectral density you are having 10 power minus 6 watt per h, 10 power minus 6 watt per h, okay, into that is your input power spectral density. Now we are multiplying with magnitude of transfer function square. Here in the denominator you can take 4 as common, 1 by 4 into 1 divided by 1 plus pi square f square. Okay, so this is the output power spectral density. Now here we have to find out the power, that is nothing but integration, that's all. Expectation of y square of t is equal to, here 10 power minus 6 divided by 4, that is a constant we can keep outside. Now we have to perform the integration from minus infinity to infinity. Then here you are having 1 by 1 plus pi square f square into df. Okay, now here you can observe you are supposed to perform integration with respect to frequency, and this function, is it even function or odd function? All of you confirm whether this function is even or odd. 1 by 1 plus pi square f square. Even function, yes or no? Because in place of f, if you put minus f whole square is nothing but f square only. That means it is an even function. Whenever you are getting even function, if you are supposed to perform integration on both negative frequency axis and positive frequency axis, that one you can represent as 2 times integral 0 to infinity. I hope all of you are getting clarity. This property you might have studied in the maths. Okay, it will applicable with respect to time domain, with respect to frequency domain, or with respect to x, or with respect to y, whatever the integration term you are performing. Okay, right. So here I am writing 2 into 10 power minus 6 divided by 4 integral 0 to infinity 1 divided by 1 plus pi square f square df. Okay, I hope all of you know one property regarding the derivation of tan inverse. Okay, just for reference here I am mentioning, like derivative of tan inverse ax, derivative of tan inverse ax. Here tan inverse x, derivative you will be getting 1 by 1 plus a square x square, and then here ax derivative with respect to x you are getting a. Okay, now you can correlate here. See, derivative of this function is nothing but this one. That means integration of this function is nothing but tan inverse ax. Okay, now when you compare here denominator you are having 1 plus pi square f square. That means here a is nothing but pi. Okay, here numerator you should have a. That means pi, but here it is not there. Multiply and divide with pi here. Okay, here 2 times 10 power minus 6 divided by 2. Here I am multiplying and dividing with pi. Now what we can write? This particular function we can write it as tan inverse ax format. Here a is nothing but pi, x is nothing but f, that's all. 10 power minus 6 divided by 2 pi, you are getting tan inverse pi f. Now the limits you can substitute 0 to infinity. When you substitute the upper limit, tan inverse infinity is nothing but 90, whereas tan inverse 0 is 0. So dash step I am writing 10 power minus 6 divided by 2 pi into pi by 2 minus 0. Okay, so from here you are getting 10 power minus 6. Okay, so here pi will get cancelled, then you are getting 1 by 4, that is nothing but 0.25 into 10 power minus 6. So 10 power minus 6 we can write as micro, so you are getting 0.25 microwatt. Okay, since it is the expectation of y square of t, that is nothing but power of the y of t, so units will be in the order of watt. Okay, so answer for this question is option B. 0.25 microwatt. I hope it is clear for everyone. Okay. So for solving this question, you should have this basic integration formula. Okay. See, whenever if you are unable to recall directly the standard integration formulas, at least whatever the derivative formulas you are having, just recall. From there, you can, if you apply integration on both sides, from there you are getting inverse. Okay. With respect to that integration format, you can get the corresponding internal term. Okay. Right. Now all of you give a try. This is a direct question. I hope all of you can answer this question easily. I am giving 1 minute time. This is the MSQ question. Either one option or more than one option can be correct. Yes, Nobita, it is MSQ question. So whenever you are having the question format like this, choose the correct option or options. That means it is MSQ. Okay, in the exam there won't be any confusion. They will specify. Okay, after the question, if it is MSQ, they will mention. And of course, in the exam, like for MCQ question, you will be having like radium button. That means you are having 4 choices. Okay, at any time you can select only one option. Whereas for MSQ, you will be having check boxes, rectangular shape. So you can select multiple options. Okay, in that manner you can identify based on the whether they have mentioned like circles regarding the options or whether they have put the check boxes. Of course, they will clearly specify whether it is NIT or MSQ or MCQ. But here in our class, just for reference, here I have mentioned the sentence framing like this. Of course, for whichever question you are having the doubt whether it is MSQ or not, you can mention. I will tell the whether it is MSQ or not. Yes, very good, Nobita, very good. Okay, for this question 3 choices are correct. So here it is very simple. Just now only we have discussed regarding power spectral density. It is very simple. Power spectral density means what? We are distributing power over range of frequency. That means units you are getting what? Units you are getting watt per hertz. Watt per hertz. Okay. So, yeah, power spectral density. Power spectral density units you are getting watt per hertz. So here it is very simple. Numerator you are having power and denominator you are having over which range of frequencies we have distributed that power, like that, right? So definitely range of frequency or bandwidth, you can say that frequency value are always it will be positive. And when you are calculating power, definitely you are getting positive value. If you are taking the ratio of 2 positive values, definitely the overall value will be positive. Okay, right. So that means here power spectral density will be greater than or equal to 0. Just like here, you can observe in earlier question also. Here we are having 10 power minus 6 watt per hertz, right? So that 10 power minus 6 is nothing but what? Positive value only. Okay. And here also from this basic definition also you can correlate. Okay. Next. Here we are performing integration of the power spectral density. Just now only we have discussed whenever you are performing integration of the power spectral density, it is very simple. integration is nothing but area under the curve. Okay, so here power spectral density units you are getting watt per hertz. Here you are performing integration with respect to frequency. Frequency units are hertz. Hertz, both are getting cancelled. Finally, you are getting in terms of watts, right? In terms of watts. You can observe after solving this question, here we got in terms of watts. That means it indicates average power. Okay, so integration of power spectral density is nothing but average power. So this is also correct. Next, here you are having, see, regarding autocorrelation function, I hope all of you know it will satisfy even symmetry. Similarly, power spectral density also will satisfy even symmetry. So that means this is also correct. So A, B, C, all the three options are correct. For this question, three choices are correct. Right. Next question, all of you give it, right? See, this question is similar to one of the earlier question which we already covered, but only difference in this question. So earlier question, one of the earlier question you are having regarding the LTI system, h of t. For that we have calculated the h of f, and from there we have calculated the h of f magnitude and then square, like that. But in this question you can see the beauty of the question. So you are having one LTI system. For that, input random process is x of t, output random process you are getting y of t. Regarding that particular system, already they have given the characteristics with respect to magnitude of transfer function square. Magnitude of transfer function square already they have given. That means magnitude of h of f whole square already they have given. You don't need to bother anything. Okay. So here regarding h of f magnitude and then square, here the spectrum exists from minus 5k to 5k. You are having the function like this. Okay. Right. Now, regarding two-sided power spectral density of the random process x of t, you are having 1 into 10 power minus 10 watt per h. Now, regarding the y of t signal, we have to calculate the power, that's all. Power of the output process y of t. Power of the output process y of t. So it is very simple. Whatever the formula here just now we have discussed. See, first of all, output power spectral density, you can write it as input power spectral density into magnitude of transfer function square. After that, you have to perform integration, that's all. Yeah, Hemant, actually in this particular session, whatever the last 4 chapters of communication we are having, I am discussing, okay, with respect to every chapter. And as I mentioned earlier, yesterday you have asked that all the formulas regarding communication system subject. So our team has already put in the comment section of yesterday lecture. So that video you can watch, okay, so that you will be getting regarding first chapter to the last chapter of communication system subject all the important points and formulas, okay. And as I mentioned in the yesterday class, today after this live session over, okay, at the end of this particular session, okay, like our team will update in the comment section whatever the gate score booster I have done regarding communication in one of the earlier year, that session link we will be putting, and along with that, okay, we will be putting one more link also, whichever gate PYQs I might have done earlier in our YouTube channel, that entire playlist link also we will be putting, so that you can go, you can refer those videos. Definitely you will be getting, in order to maximize regarding communication system subject, because I have seen your comments and the way you are appreciating. So I am very much happy because you are regularly watching our lectures and you are getting benefited. So since we are having, whatever the time, limited time we are having, so in that limited time we are making sure that how much maximum we can give in such a way that each and every student are able to get maximum benefit from our lectures. Since whatever lectures which we have done earlier, definitely our team will be putting today at the end of after this session is getting over in the comment section. So whoever want to get, whoever having more time, that if you want to enhance your knowledge and in order to score well in the communication system subject, so for them our team will put whatever the links are available in our YouTube channel that I have already done earlier. Definitely we are putting, so that you people can best utilize in order to score well in the upcoming GATE exam. Okay, right. Yes, very good. Yeah, very good, Hemant, very good. Yeah. So here whatever the formula here we have discussed, once again we can use same. Once again we can use same. Yeah, no issue, Akanksha, no issue. Yeah, good evening, good evening. So once again we are using same formula. Here in this question, already you are having magnitude of transfer function whole square regarding that characteristic you are having, right? And here if you observe here, we have to perform integration of this entire function. Anyway, this is the constant we can keep outside. Then you are supposed to perform integration of magnitude of transfer function square df, right? Okay. So with this understanding, now directly I am writing here. So here expectation of y square of t, is equal to, so here integral minus infinity sy of f df. This is the output power spectral density integration, right? Now, so this one you can write it as Sx of f, that means input power spectral density into magnitude of transfer function square. Right? Okay. Sx of f already you are having 1 into 10 power minus 10 integral minus infinity to infinity 1 into 10 power minus 10. Okay. Now you can observe. Okay, this one I am keeping as it is magnitude of h of f whole square. See, initially some of you might have thought for solving this question it is a tough, but once if you use the basic formulas, anyway this is the constant we can keep outside, right? So 1 into 10 power minus 10 we can write as 10 power minus 10 now you are having minus infinity to infinity integration, then magnitude of h of f whole square df. Now what is the meaning of this one? Just all of you mention in the chart. What is the meaning of this one? Forget about this 10 power minus 10. Integral minus infinity to infinity magnitude of h of f whole square df. That means what is the meaning of it? If you are able to get the hint from this particular equation, after that you can do in one step, that's all. Yeah, just observe here, it is very simple. Here you are having what? Integration. Integration means what? Area under the curve. Here you are having what? The function itself is magnitude of h of f whole square, right? So you can observe here that particular function only here you are having, you have to perform integration. Now it is very simple. See, whenever you are having the standard waveforms or standard functions, and if you know area of that particular function or signal, like suppose triangle signal or rectangle, square, etc., whichever standard functions or standard shapes or waveforms, if you know area of that particular waveform or pattern, definitely you can use that property. But in whichever case you don't know area of that particular pattern, then definitely you can use regular mathematics, that's all. Okay, but while you are solving the communication system subjects, okay, questions, most of the cases you will get that hint. Even like this hint, you can apply even in network theory also, even in signals and system also. Wherever you are getting integration and for whichever function you are supposed to perform integration, that is nothing but area under the curve. If you know the area of that particular pattern or shape, then directly you can use. Of course, whatever the value you are getting by using area formula, the same value you can get even if you are using regular mathematics, but that may take more time. Say for example, if you want to solve this question with respect to your mathematics, you can give a try later and you can check how much time it is taking. Definitely it will take more time, because here you will be writing this equation, here you will be writing this equation. After that, here you are putting minus 5k to 0 and then 0 to 5k. After that you are doing the integration. Definitely it will take more time. But here if you observe, even though you are having minus infinity to infinity, but here according to this particular spectrum, it exists from minus 5k to plus 5k. That's all. Okay, so just I am modifying the units here. 10 power minus 10 integral minus 5k to plus 5k, right? Magnitude of h of f whole square df, right? Here the hint point is area, that's all. Area under the given graph. Very good, Nobita, very good. Now here if you observe, you are having one triangle. See, in the interval minus 5k to 5k, you are having one triangle shape, right? I hope all of you know area of the triangle. Half base into height, that's all. Half base into height. Okay, that property we are using. Half base into height. Here base is how much? 10k into height. Height you are here you are having 1 unit. Okay, this is area under the curve, and after that we have to multiply with 10 power minus 10. Right? So from here you are getting 1 by 2, or you can write here 2 5 times, then 5 into 10 power 3 into 10 power minus 10. We can write it as 10 power minus 7 units are what? Okay. So you can have the observation of the choices. 5 into 10 power minus 6. No, that is not correct, because here you are getting 10 power minus 7. Okay, so that means we can eliminate this choice. Right. So from here just rearrange this one. Here this one you can write it as 0.5 into 10 power minus 6. because 10 power minus 7 you can write as 10 power minus 6 into 10 power minus 1. 10 power minus 1 you can write as 1 by 10. 5 by 10 is nothing but 0.5. Yes, 0.5 into 10 power minus 6, that is there in option C. So that means other two choices we can eliminate. See, in this way, if you are solving these kind of questions, or if you are practicing these kind of questions, definitely with the help of this logic, when you are attempting the gate questions, if you are coming across like this models, definitely you can solve. But when you are solving these kind of questions very first time, no matter, even though you know the basic formulas, after this you might be stuck in. Okay, no issue. That is the reason here in our gate score booster sessions, we are making sure that each and every sincere student is getting maximum benefit from our series of lectures in order to maximize the score in the upcoming gate exam. Okay, right. So I hope it is clear for everyone. For this question, the final answer is option C. Option C is the correct answer. Yeah, Akansha, you can observe here. Here you are having integral minus infinity infinity h of f whole square df, right? Already here the given function itself h of f magnitude square only. Is it clear, Akansha? Here already they have given magnitude of h of f whole square. That is the reason we have used directly. See, in the previous question, since you have joined late, okay, no problem. See, you can observe in this question. In this question, that question, both are similar only. But in this question, regarding the LTI system, you are having the impulse response. H of t you are having. H of t you are having. For that h of t, we have applied the Laplace transform. After that, in place of s, j omega, we have substituted. From there, h of f we got, magnitude we have considered, and then performed the magnitude square. Like this we calculated. After that, we have performed the integration. See, this is one approach when you directly don't have the corresponding magnitude of transfer function square. Okay, but here in this question we solve like this. Okay, this is the approach. Okay, whereas in this question directly you are having magnitude of transfer function square characteristic. Since already given, that is the hint point for solving this question. Okay, right. Yeah. Next question, I hope all of you can give a try. See, this is the question I have kept here, but when you read the question, you may feel that, sir, this question belongs to mathematics regarding random variables concept. Yes, I am agreeing, but only difference here in the same question, if we are introducing the word random process, that means x of t, y of t, etc., then that particular question will belong to communication, like that. Because in maths you are studying only random variables and then probability, right? Probability and random variables, whereas continuation of that random variables is random process. Yes, very good. All of you are getting correct answer. For this question, two choices are correct, A and C. Very good. This question is of MSQ. So here variance of Ax plus B. I hope all of you know these properties. When you're having variance of Ax plus B format, so this one we can write it as just like expectation operator. We can perform. It is a linear operator, like that we can expand. So here we can write variance of Ax plus variance of B. Variance of B. Okay. So regarding variance of Ax, here you will be getting A square into variance of x, whereas variance of constant, what is the value of this one? Earlier we have discussed expectation of constant is constant. Now here variance of constant is how much? 0. Yes or no? Variance of constant is 0. So from here you are getting A square into variance of x. See, it is very simple regarding this particular property. Whenever you are having variance of Ax, you can write as A square variance of x, or when you are having variance of Ax plus B, that is also same, A square into variance of x. Okay. So from here we got two conclusion points. Okay, both I am writing here. Variance of Ax. So this one you can write as A square into variance of x. Now by using these two properties, we can choose here among the four choices whichever options are correct. Right. So here you are having variance of 5x plus 4, that is nothing but. So in option A I am considering. So here you will be having 5 square into variance of x. 5 square is nothing but 25 into variance of x. Yes, 25 variance of x, that is correct. So the moment here option A correct, option B won't correct, because in both option A and B we are having left hand side same equation. Okay. Now here variance of 3x, so here 3 square into variance of x. 3 square is 9 into variance of x. Okay, right. Since option C is satisfying, obviously option D won't satisfy. Okay, these are the basic properties regarding variance. Earlier we already covered regarding expectation. Suppose if you are having expectation of Ax plus B is nothing but A into expectation of x plus B. Okay, expectation of Ax is same as A into expectation of x. Right. Next question. I hope all of you can answer this question. You might have studied regarding figure of merit. Figure of merit with respect to AM and FM receivers. Even though this concept belongs to the previous chapter, third chapter, but in order to solve the questions based on figure of merit, the noise analysis part is a prerequisite, because here we are discussing SNR calculation. That is the reason I have kept this question in the fourth chapter. But concept wise, it belongs to the third chapter, AM and FM receivers. Figure of merit. Figure of merit should be unity in which receivers. Unity means 1. Unity means 1. Among these four receivers, in which cases figure of merit you will be getting 1. Yes, very good Akanksha, very good. Here you will be getting in two cases, option A, option D. See, regarding figure of merit for AM, whatever the formula we got for modulation efficiency with respect to AM, exactly same formula. That means mu square by 2 plus mu square. Mu square by 2 plus mu square. Okay. Whatever the modulation efficiency we got with respect to AM, exactly same formula you will be getting for AM, even for figure of merit. Okay. Coming to the DSBSC, SSBSC and VSBSC. In these three cases, you will be having figure of merit as 1. Figure of merit as 1. See, with respect to AM, modulation index at max, how much value will be considering with respect to AM? Or in general, modulation index value range is what? Less than or equal to 1. That means max value allowed to take 1. So when you are substituting mu value 1, so you are getting 1 by 3. Here figure of merit you are getting 1 by 3. Whereas DSBSC, SSBSC, VSBSC, figure of merit is 1. Okay, right. Now, coming to the wideband FM. Sorry. Yeah, figure of merit for FM, you will be getting 3 by 2 into beta square. 3 by 2 into beta square. So, among all, okay, see when you are considering wideband FM, definitely beta value will be what? Greater than 1. Let us consider beta value 5. Beta value 5. So 5 square is nothing but 25. 25 3 is 75 divided by 2. Okay. So when compared to DSBSC, SSBSC, VSBSC, figure of merit in wideband FM is more. Okay. So that is the reason among all the receivers, if you want to select any one receiver, okay, so definitely you will be receiving best, you will be choosing best receiver. Definitely wideband FM is the best, because here, see when you are doing the figure of merit, you are taking the ratio of output SNR divided by the input SNR with respect to receiver, right? Even though like noise part has been included, because here we are doing the modulation in terms of frequency. Whenever you are using the modulation in terms of frequency, the noise effect we are able to eliminate, okay, or we can say we are able to minimize, okay. So that is the reason among all the receivers with respect to first chapter and second chapter, FM is the best, okay. But with respect to the bandwidth wise, or with respect to the power required for transmitting the signal, etc., generally we are considering SSBSC, because when you compare with any of the modulation technique, definitely in SSBSC, the power required for transmitting the signal is less, the bandwidth required for transmitting the signal is less. But among the, like when you have compared with the figure of merit, among these two, this is the wideband FM is the best. Okay, I hope all of you got the clarity with the help of this simple question. Right. Next one. So far what are the questions we have discussed regarding fourth chapter, that is random process and noise. Now we are going to discuss the questions regarding fifth chapter, that is digital communication, baseband data transmission. Okay. Yeah, Nobita, this question is MCQ only. Yeah, everyone thought that this question is MSQ, but actually read the question here in the last line. Okay, if you read this line, you will come to know this question is MCQ, not MSQ. Okay, no issue. Okay. So here I have asked that choose the incorrect option. Okay, everyone thought that choose the correct option or options, right? Okay. So here the context of the question is important. That is the reason I am putting once in a while, okay, when you people are on track, okay, I am putting like this twist so that how many of you are really, paying more attention, okay. So this is the most important. See, when definitely you can solve the question correctly, but according to the context of the question, whether you are able to choose the correct option or not, that is also most important, okay. So that is the reason this is the great learning for all of you in the GATE exam. After solving any question, before you are choosing the option or before you are entering your answer for NIT question, once again read the context of the question and re-verify whether according to the context of the question whether my answer is correct or not. If you feel your answer is correct, then accordingly you can choose like that. Yeah, very good Akanksha and Nobita, very good. For this question, option D is the correct answer, because whatever the statement here you are having, that particular relation is not correct. Okay, right. Fine. So here first of all just read the question. A modulating signal having bandwidth. Modulating signal bandwidth we have already mentioned yesterday class also. Regarding modulating signal, bandwidth means that is nothing but FM. So FM we are having 5 kHz, right. Next, is sampled at 50% above the Nyquist rate. 50% above the Nyquist rate. So that means here Fs is nothing but, see, suppose Nyquist rate you are considering like this, okay, and here in this question it is mentioned clearly sampled at a rate 50% above the Nyquist rate. That means for the Nyquist rate you have to consider extra 50%. 50% I am writing as 50 by 100, both are same. Okay, so 50 by 100 you can write it as 0.5. So 1 plus 0.5, that is 1.5. 1.5 times Nyquist rate. So regarding Nyquist rate, I hope all of you know that is 2 times FM. 2 times FM. Okay. Right. So from here you will be getting 1.5 into 2, that is nothing but 3 into FM. So here FM value already you are having 5K. So you can substitute this value here. From there you are going to get 3 into 5K, that is 15 kHz. 15 kHz in general we are representing, but whenever you are having sampling rate, okay, so that time if you want to represent number of samples per second, because frequency units are what? Per hertz. Okay, here sampling rate means number of samples per second. Ultimately you are getting per second. Okay, right. So you can consider in any manner. Okay, 15 kHz you can consider, or 15K samples per second. Okay, in the questions, like whatever the options you are having, both the options you can consider like synonymous only. Right, here 15 kHz, yes, option A is correct. The same thing, just for reference here I am mentioning, like 15 kilo samples per second also you can consider. Samples per second, both are same only. Okay. Right. Now here in this question, you can observe further. Here we have quantized into number of, we have quantized into 256 levels. That means number of quantization levels are 256. L equal to 256. I hope all of you know the relation. L equal to 2 power in generalized case. Since we are having in this question 256, exactly you are getting perfect 2 power, right? So from here you are getting n value as 8 bits. So here we are using 8 bits per sample. For every sample we are using 8 bits. Okay, right. So here option B is also correct. Option B is also correct. Next, sorry, here just one second. Whatever the options you are having A and B, that relations are correct. Okay, right. But here we have to choose the incorrect relation. Okay. Now bitrate. Bitrate is nothing but sorry, yeah, bit rate, that is nothing but RB. See, it is very simple. Bit rate is nothing but how many bits you are transmitting in 1 second. Okay, so that means ultimately units you should get in the order of bits per second. Bits per second. Now just observe these two. Here bits per sample, here samples per second. If you multiply these two, samples are getting cancelled, you are getting bits per second. That's all. Okay, so that means the formula is very simple, N into Fs. So that is the reason, according to the context, you can consider the units accordingly. Okay, right. So here n value is 8, and here number of samples you are having 15k. 8 into 15, that is nothing but 120 kilo bits per second, 120 kbps. So this is also correct relation. Since option A, option B, option C are having correct relations, definitely option D, whatever you are having the relation, that won't be correct. Hence, it is the correct answer for this question. Okay, right. So later in your free time, just give it a try. It is very simple. Whatever RB currently you got, just you have to take the reciprocal. That's all. Okay, from there you can find out the bit interval. All of you give it a try. Whatever the number here you got 120k, just do the reciprocal. How much you are getting, tell me. RB equal to 1 by TB. So from here I am just rearranging. TB equal to 1 by RB. So RB we got 120k. Here you are having in the order of microsecond. So here I am putting like this, 1 by 12 into 10 into 10 power 3. We can write as 10 power 4, right? Multiply and divide with 100. So that here 10 power 4 into 100 you can write as 10 power 6, that you can bring into the numerator. It will become 10 power minus 6. Yes, very good, Nobita, very good. Yeah, from here you are getting this value as 10 power 6. That one if you are bringing to the numerator, it will become 10 power minus 6. Right. Next, 4 3s are 12, 4 25s. So 25 by 3, you are getting 8.33. Very good. 8.33. Here units are second. So this one we can write as 8.33 microsecond. But here in this question I have given 5.33. It is not equal. Okay, suppose the same question, if it is MSQ and if you are supposed to choose the correct option or options, then whatever you people have mentioned A, B, C, those are correct choices. Okay, so in this way you can get regarding MCQ or MSQ. I hope whatever the questions we are discussing in our sessions, with the help of these questions you are getting to know regarding the concept and regarding the method of solving, and even regarding the variety of questions, in which model or in which way you can get the pattern in the GATE exam. Okay. Right. With this understanding, now let us see the next one. Yes, sorry. Here I have included here. Okay, no problem. Yeah. Now all of you give a try regarding this question. This question MCQ only. This question MCQ only. Yes, very good, Akansha. Very good. Excellent. So first of all, read the question. You are having the message signal m of t equal to am cos 2 pi f m t. Okay. That signal is sampled and transmitted through a channel using 4-bit PCM. That means number of bits given as 4. Then, in this question, you are having the data quantization error maximum. That value is 0.625 volts. Quantization error maximum is 0.625 volts, and RB, that means bit rate you are having 64 kbps. 64 kbps. Yes, very good, Nobita. Very good. Then choose the correct option. For this question, okay, only one correct option will be there. Okay, you have to choose that correct option. Note that the sampling rate is twice the Nyquist rate. Okay, here you are having option A, peak amplitude of message signal, option B, maximum frequency of the message signal, and option C is there, both A and B are correct. Okay, option D is none of the above is correct. Now we have to verify, okay, each by one by one. Now, first of all, let us consider this one, quantization error maximum. Quantization error maximum is nothing but what? Delta by 2, half of the step size. In general, the quantization error is varying from minus delta by 2 to plus delta by 2. So, among all the values, the maximum value is plus delta by 2. So, delta by 2. Here, delta is nothing but step size, half of the step size. Okay. So, with respect to generalized case, here delta is nothing but what? Dynamic range divided by number of quantization levels. So, dynamic range is nothing but maximum value minus minimum value. So, with respect to cos signal or sin signal, maximum value here you are having plus am, minimum value you are having minus am. So, from there dash step I am writing 2am. See, in general you will be writing maximum minus minimum. Maximum is plus am, minimum is minus am. Am minus of minus am, that is 2am. Okay. Divide by number of levels. Here n, for n bits you are having 2 power n. Okay. Now this 2 is getting cancelled. 2 is getting cancelled. So you are getting am by 2 power n. Right. You are getting am by 2 power n. Okay. Now according to the question, here you can consider QE max already given as 0.625, that is equal to am. In this question you are having number of bits are 4. Okay, so that means 2 power 4. Just do the cross multiplication. You are getting am equal to 2 power 4 is 16 into 0.625. You can do simplification. You will be getting 10 volts. Am equal to 10 volts. Okay, so as of now am value is satisfying. Now we have to decide regarding Fm, whether it is correct or not. So in order to decide regarding that, we have to use this data, bit rate. Okay, RB equal to n into Fs. Okay, here in this question we are having 64 kbps. 64 kbps. Now RB is nothing but n into Fs. N into Fs. Now here n value given 4. Fs in this question given as sampling rate is twice the Nyquist rate. Twice the Nyquist rate. So 2 times Nyquist rate. Nyquist rate is 2 Fm. Dash step I have written 2 times Nyquist rate, where Nyquist rate is 2 times Fm. Now this overall value is same as 64k. So here just observe 4 2s are 8, 8 2s are 16, 16 here 4 times. Okay. So that means here you are getting Fm equal to 4 kilohertz. Yes. Here option A, option B both are satisfying, and the question is MCQ type, So that means now you can choose. Final answer for this question is option C. Suppose the same question, if it is MSQ, then what will be the correct options? Same question, let us consider it is MSQ, then which options you will be choosing? If the same question, if they mention MSQ, choose the correct option or options. In that case, which options you will be choosing? Yes, very good, Akanksha, very good. See, since A is correct, B is correct, and even C, option C is also correct. That means 3 correct options are there, according you can choose. But since this question is MCQ, only 1 correct option will be there. That is the reason you can choose option C in this question. Okay, right. Yeah, next question, all of you give a try. I am giving more time, all of you give a try, because it may take more time. Yeah, for this question, generally few students may do silly mistake. What is that silly mistake they may do? Since they have given signal to condensation noise ratio, generally students may use, okay, because here you are having in the order of decibels, some students may use 1.8 plus 6n. See, that equation we got provided when the given message signal is either sine or cos. Okay, with respect to that message signal either sine or cos, in the derivation after doing the simplification, we got 1.8 plus 6n. That is the note point. Okay, whenever in the question if they don't specify whether the signal is sine or cos, we are not allowed to use that 1.8 plus 6n. That is the learning. That is the reason I have given here 5 minutes time. Okay, some of you might have thought, sir, like why sir has given 5 minutes time for solving this question. Okay, see, if it is 1.8 plus 6n, I could have given 1 minute time only. Okay, that is, so here even though it is mentioned that particular signal varies between these two, but they haven't mentioned whether it is sine or cos. Okay, whenever they not mentioned, don't take it as granted. Okay, right. Now, so in this question, just read the question first. Bandwidth of the input to PCM system modulator is 4 kHz. That means FM you are having 4K, right? Then the signal varies from minus 3.8 to plus 3.8, and regarding that particular signal they have given the power. So that means signal power they have given 30 milliwatt. 30 milliwatt they have given. Yes, very good, Ricky. Very good. Very good. Signal power they have given 30 milliwatt, and signal to condensation noise ratio having 20 decibels. Assume uniform condensation, the number of bits required for sample. Okay. So in this question you are having signal power. Okay. So signal to condensation noise ratio, here you are having in the decibel format. Okay. From there let us get the normal form. So just for reference here I am mentioning SQNR in dB. SQNR in dB we are having 20. So if you want in the normal, that means 10 log SQNR. 10 log SQNR is nothing but 20. Okay. So from here 10 2 times. Here base value, whenever you are performing logarithm with respect to SNR or SQNR, by default logarithm base value will be 10. Okay. So from here you are getting SQNR equal to 10 square. SQNR you are getting 10 square, that is nothing but 100. This is the normal value. Since it is the ratio of signal power and noise power, definitely units will be like constant. There won't be any units. Okay, right. So in this question already you are having signal power. Okay, this SQNR you can write it as signal power divided by condensation noise power. Signal power divided by condensation noise power. Okay, noise power for the timing I am representing as n suffix p. So that is equal to 100. Right. So this one I am labeling as equation number 1. Here we know signal power. Regarding noise power we don't know. Condensation noise power, I hope all of you know the formula, delta square by 12. Delta square by 12. Okay, this formula you can remember. Condensation noise power, delta square by 12. Now, here delta is nothing but, in the previous question also we have discussed, Vmax minus Vmin. Okay, Vmax minus Vmin. Here Vmax is 3.8 minus Vmin also same, minus 3.8. Vmax minus Vmin divided by number of levels. Number of levels, that is nothing but 2 power n. This whole term square. This whole term square. Vmax minus Vmin divided by number of levels whole square. That is nothing but delta square. And then here you are having 1 by 12. I hope it is clear for everyone up to this step. Okay. If any of you are getting any confusion regarding this part of solution, you can mention in the chart. I will clarify. This is a very, very interesting question. Even though the students have learned this concept very well, still some students are doing a silly mistake regarding this kind of question while they are attempting in the GATE exam. Okay, right. So that is the reason I have put this question here, so that like in the communication system subject, wherever in general students may do silly mistake, or wherever students, even though concept wise good, but while solving some of the questions they may do misconception. Okay, so because of that, whatever the wrong answers you might be getting, so or whatever the silly mistakes you are doing, so all the areas I will be covering, so that all these are great learnings for you in order to maximize your score in the communication system subject in the coming GATE exam. Okay, right. Now here you can do further simplification. So here 3.8 plus 3.8, that is nothing but 7.6. Okay, 7.6 divided by 12 into 2 power 2n. 2 power n whole square, that you can write as 2 power 2n. Just like a power m whole power n is nothing but a power mn. Right. So this is the noise power you got. This noise power here you can consider. Signal power already you are having 30 milliwatt. Now you can do further simplification. That's all. Okay. Yeah, Akanksha and Nobita, you can give a try now. Okay, I have given the help. I have given the hint for you. At least in the equation 1, signal power already given, noise power just now we got. Okay, these two you can substitute and do further. Okay, and try to get the n value. So here signal power given as 30 milliwatt. Signal power given as 30 milliwatt, that we can write as 30 into 10 power minus 3. 30 into 10 power minus 3. Okay, divide by noise power. 7.6 divided by 12 into 2 power 2n. 12 into 2 power 2n. Okay, signal power divided by noise power, that is equal to 100. Right. So here 1 0 will get cancelled. Next, you can do further simplification. So here this term is coming numerator. Right, 3 12s are 36. 3 12s are 36 into 2 power 2n into 10 power minus 3 divided by 7.6 is equal to 10. Okay, you can do cross multiplication. From here you will be getting 2 power 2n is equal to 10 into 7.6, that is 76, divided by 36 into 10 power minus 3. So this 10 power minus 3, okay, I am representing here. In the next step I will do further simplification. So here 2 18s, 2 38s, 2 9s, 2 19s. Okay. So after that you are getting 2 power 2n equal to 19. Here 10 power minus 3 I am bringing numerator, it will become 1000 divided by 9. Okay, you can do simplification of this one. From there tell me how much you are getting for n value. N value will be getting 7 bits, right? Yeah, 3.8 plus 3.8. Yeah, very good, Ricky. Very good. Sorry. Here 7.6 whole square. Very good. 7.6 whole square. Right. So here 7.6 whole square. Okay. This part of the representation I am cancelling. Okay. Right. So this equation you can do simplification. From there you will be getting 7 bits. 7 bits. Nobita, is it clear? Yes, Akanksha, as I mentioned earlier, whatever the questions we are discussing yesterday and today, these questions will be sufficient, and after solving these questions, okay, so as I mentioned yesterday also, whatever the quick revision session link I have shared, our team has shared in the yesterday session at the comment section, that you can refer. So regarding entire communication system subject, you are getting all the important points and formulas, okay, which are very much important for solving the questions of communication. And today, after this session over, in this particular session link at the in the comment section, our team will put whatever the score booster questions I have discussed regarding communication system subject in one of the earlier year, that links we will be putting, and whichever like in our YouTube channel regarding communication system subject, I have done some previous year questions, important questions, and interesting questions, that also I have done earlier. That playlist link also our team will be putting today only, so that if you are having some extra time, and since you want to score, or in order to maximize your score in communication system subject, this much you do, okay, whatever you have attended yesterday and similarly today, definitely with the help of these two sessions you are getting 40 questions, right? After that, you are going through the quick revision session. With the help of that, you are getting each and every important point and formula, and after that, like this score booster session I have done earlier, so you can solve those questions also with the help of whatever the confidence you got from these two sessions. Definitely you can check there also. You will be getting further enhancement in order to score well. And after that, just check whatever the gate questions I have discussed in that playlist. Okay, I have discussed from recent year to the some earlier years, few years I have discussed in the continuation. Just have a check whatever the gate questions there I have discussed, how many questions you are able to solve the correctly, like that you can check, and based on that, whatever you are expecting, definitely you can reach. Because in the EC paper, generally I used to say E stands for EDC. Of course, if you want, you can consider E stands for EMFT as well, and C stands for communication. So regarding EDC and analog, together you will be getting huge weightage, and similarly communication and EMFT, together you can get very huge weightage. So whoever want to get very good marks or very good rank, I can say, in the GATE exam, along like after you become perfect in the common subjects of EC, electrical, IN, based on your free time, how much extra you can put in terms of revision or practice, you can put for communication, EDC, EMFT, analog. Definitely you can get very good rank. And just I want to give the confirmation regarding communication system subject, you will be getting in the GATE exam 8 to 12 marks. 8 to 12 marks. 8 is like minimum marks, 12 is the max marks in the GATE exam. Similarly, regarding EDC, you will be getting 8 to 12 marks. Okay. So if they are giving 12 marks in the GATE exam, whatever I have told, this much limited, like whatever YouTube links we are giving, definitely you solve those questions. Okay, definitely like whatever the marks, let us consider out of 12 marks, you can easily get 6 marks. But more than that also possible. But like what I mean to say, in the given time, suppose some question if they are giving very much tricky, which in order to solve, if it is taking 20 minutes, definitely you should not solve that question in the GATE exam, because 20 minutes after you are investing, ultimately at max you are getting 2 marks. That is not the good strategy in the GATE exam. So like that, I mean to say, let us consider 2 questions you are getting, very tricky questions which may take more time. Those 2 questions you are leaving. So in that case, out of 12 marks, you are getting 8 marks. Okay, like that possibility is there. And after doing this much, still, sir, I am having some more interest, I want to do something further, then no problem. In our YouTube channel, IMS GATE Academy YouTube channel, just click on the playlist. One of the playlist name you can see with my name, JP sir videos and shorts, like that. So that particular playlist also, just have a look. Whichever videos, either videos or shorts you are having related communication system subject, just have a check, that's all. Okay, this much if you do, definitely, since you are putting efforts, I am able to see the way you are solving the questions. Okay, it is like you are on par, so definitely you can easily get. Okay, right. Okay, so with this, Okay, now I'm showing the next question. All of you give it a try. Yes, very good, Nobita and Akanksha, very good. Here the question is regarding delta modulator. Delta modulator. So delta modulator is a special case of DPCM, differential pulse code modulation. So in the pulse code modulation, we are giving directly analog signal. From that analog signal, we are taking the samples and then quantization encoding. Whereas for differential pulse code modulation, before the quantizer, we are giving the like the present sample and the previous sample. We are comparing and the difference we are giving. Okay. So now that differential pulse code modulation, okay, if you are taking like one bit, say for example, if the difference you are getting, the difference of present sample with the previous sample, if the difference you are getting positive, that means we are considering like one step we are incrementing. If the difference is negative, one step we are decrementing. So that means in order to represent either one step increment or one step decrement, one bit is sufficient. That is nothing but one bit DPCM is nothing but delta modulator. Okay, right. So here option A is correct. Delta modulator is nothing but, okay. So here statement wise correct, but here we are asking incorrect option. Choose the incorrect statement. Okay. So that whichever option you are having incorrect statement, that will be the correct answer for this question, right? So delta modulator is nothing but one bit DPCM. That is a correct statement. Okay. Since we are telling, see, for PCM and DPCM, the formulas will remain same regarding bit rate. So with respect to PCM, we are having bit rate formula n into fs, n into fs. The same formula will applicable in DPCM. And just now we have mentioned n value is 1. So when you are considering n value 1, you are getting RB equal to fs. That means bit rate and the sampling interval or sampling, sorry, bit rate and sampling frequency, sampling rate, both are one and the same. Both are one and the same. So bit rate of delta modulator is equal to sampling frequency of the modulating signal, statement wise correct. Okay. Now from here, RB you can write it as 1 by TB and Fs we can write as 1 by Ts. From here we can write bit duration is same as sampling interval, right? TB equal to Ts. So in delta modulation, sorry, yeah, here read bit duration of the delta modulator is not equal to, but here we are getting what? Equal to. Since here not equal to is there, okay, that is the reason this entire statement is wrong or incorrect. Hence this is the correct answer for this question. This is the correct answer for this question. Whereas here in delta modulation, the signal reconstruction completely depends on the value of step size delta chosen. Yes, this is the correct statement. This is the correct statement. Suppose if we are unable to choose the delta value properly, accordingly we are having two types of errors. One is slope overload distortion, another one is granular noise. Okay. Yeah, Ricky, as I mentioned earlier, whatever the links our team will update regarding yesterday's session, we already put one link. Regarding today's session, after the session is getting over, our team will put. So those links you can watch. Okay, definitely you can, matlab your confidence level will definitely increase. Because whatever the sessions earlier I have took, okay, definitely with the help of those sessions, you are getting the concept clarity, formula clarity, and in fact, the way we are solving the questions here, in fact, in those sessions, at least in some sessions you can get, especially GATE PYQ sessions list. Okay, in that playlist, I have discussed for the beginners. Okay, so in that manner, you are getting two-way benefit. With the help of GATE question, you are getting to know how to solve the given question, and related to that question, what are the concept involved or formula involved, there also I have discussed. Just like in this session also, wherever required initially, like some formulas I am discussing in detail, like that I have covered there. But currently we are doing this session before the GATE exam. That is the reason I am not elaborating each and everything, but wherever required I am giving the glimpse, right? Definitely you will get benefit. Okay, next question all of you give it, right? Yeah, I am very happy that all of you are requesting. Okay, but I am accepting all of your requests, but only thing, since I have done n number of sessions in our YouTube channel, that is the reason first I am recommending you people to go through those lectures. Definitely you can feel, in terms of knowledge and in terms of confidence regarding communication, definitely you can enhance, because currently we are having limited time before the GATE exam. Because generally we are, like say for example, what will happen, like whenever, see whatever you are already having, that you are not recognizing. What we don't have, we are running after. Okay, see that is okay, provided when you are having long time. Okay, but when you are having short time, in the limited time, by following which strategy, okay, or by following which method, you can maximize your score for the GATE exam. That is most important, because when you are having 40 days time, you should not prepare the way, suppose as though you are having 1 year time. Okay, see learning wise, it is unlimited. Even throughout your lifespan, you can study. As I mentioned earlier, in EC, C stands for communication. So the letter C, you can consider one more word, SEA, C, ocean, right? So it is unlimited, because how much you learned, still yet to learn, unlimited. That means there are no boundaries. But with respect to exam point of view, we can put the boundaries. That boundary is nothing but syllabus. So according to the given syllabus, whatever the standard models are there, expected models are there, if you are able to do, definitely with the help of that confidence, you can maximize. Okay, but if you want to learn further, that as I mentioned earlier, we are having unlimited time. Okay, you can prepare throughout our lifespan. Okay, but at least since you are preparing for GATE 25 exam, I am not disappointing you. Whatever I have done earlier sessions, okay, at this point of time, I have mentioned few important links, like that whichever I might have done earlier, I will check and I will update in future, either next week or in this week, whenever I am getting time, I will be updating in the comment section only, so that you people, whenever you are having some extra time, you can go through. But only thing, one small thing I am telling, even though I might be giving whatever links possible, but you can keep timeline. Say for example, since you are writing the GATE exam, GATE 2025, at least you try to make sure by January 15th or at max January 20, you try to complete how much you can do, that much. Okay, so that at least from January 20, you can have some 2-3 weeks buffer time, so that you can do revision of like whatever you have studied in this period of time regarding communication system subject. Once again you can do revision, because the more you are learning new things, our human tendency, we used to forget what we learned earlier, right? So that is the reason, first of all, whichever subjects you are very much confident or which you prepared very well earlier, try to do as many times revision and practice for those subjects, and parallelly regarding communication system subject, how much you can do extra. You can keep some limited time on daily basis or once in 2 days, and accordingly you can do. Definitely all of you will get benefit. Okay, right. After doing all those assignments, suppose, okay, after doing that much, you can cross verify yourself. Okay, how to cross verify it is very simple. Voluntarily you can download from official website regarding GATE official website. From there you can download recent GATE PYQ papers, right? So choice is yours. From the official website, whichever GATE year regarding EC you want to download, you can download, and you can just assess yourself regarding communication, how many marks you are having or how many questions you are having in that paper, what is the total number of marks regarding communication, that you can note down, and out of those marks regarding communication, how many marks you are able to get. Like that you can assess. Suppose, as I mentioned earlier, if you are having 12 marks in that paper, out of 12 marks, if you are able to get 6 marks easily, okay, so that means you are on track only. Because in the given time, even for the topper, some questions he also cannot solve. That is the reason in EC, even though total number of marks are 100, but generally the topper or all-India rank 1 used to get somewhere 85 to 90. Okay, so that is the reason you keep in that manner. Okay, but I am very much happy to like for all your comments that you are mentioning in the comment section or chat. I am very happy that you people are requesting regarding communication system subject. Okay, but here only one important point I want to give the conclusion. Very simple. The regarding learning point of view, the strategy is different. Regarding exam point of view, strategy is different. That is the reason whatever limited in the limited period, the way you can do in that manner, I am helping regarding communication. Okay, right. After doing this much, you can share your experience in any of the my YouTube links regarding communication system subject at our YouTube channel. In any link you can mention in the comment section, like whatever you have done preparation with the help of our YouTube links regarding communication. You can share your experience and confidence, whatever you people are expecting for the GATE exam, right? Okay. Yeah, for this question, all of you give it, right? Yeah, I am giving some time because I have discussed with some students. Okay, I will be giving some time. Yeah, Akanksha, regarding control system and signal system, it is already planned. You will be getting upcoming notification. Okay, Ankur sir will take regarding control system and signal system. So those links, those sessions will happen in future. Yeah, Akanksha, 20 mock test not required. So it is very simple. Like you can attempt, say for example, like since you are from EC, okay. So are you writing instrumentation paper also or only EC? If you are writing instrumentation paper, then weekly wise you can consider 1 mock test, and weekly wise you can consider 1 GATE PYQ. So that means 5 mock test and 5 GATE PYQ year wise papers you are attempting. That means 10 tests will be sufficient, so that on average in test series how many marks you are getting, on average in GATE paper how many marks you are getting. Okay, but if you are writing only exclusively for EC, then you can consider 6 mock tests and 6 GATE PYQs, like that. Okay, yeah. So before instrumentation exam, you can keep 5 mock test and 5 GATE PYQ. Year wise choice is yours. Okay, if you want to attempt in the recent years like 2024, 23, 22, 21, 20, like that in the descending order, you can go in the sequence, or randomly also you can go. Choice is yours. Okay. And after writing IN paper, whatever the learnings are there during the test, that you can note down, and after that you are having 14 days time. So in that 14 days time, 1 mock test, 1 GATE PYQ you can attempt. That much will be sufficient. Because 6 mock tests and 6 GATE PYQs, that is more than sufficient. Because 20 is too much. Okay, that is not at all required. Yeah, just observe this question. First of all, read the question. Yeah, you are having a digital modulator which is designed to operate at 3 times the Nyquist rate. 3 times the Nyquist rate for a signal having bandwidth 3 kHz. That means here FM equal to 3 kHz. The quantization step size, that means delta, they have given 250 millivolt. The maximum amplitude of the message signal, okay, which is having frequency as 1 kHz. 1 kHz. And here in this question you are having sinusoidal signal. Okay, right. For which the delta modulation does not show slope overload distortion or slope overload error. Simple logic. Simple logic. See, slope overload error when it will occur, dm of t by dt, if this value is greater, then it will occur. Okay. So after delta modulator, you are getting the slope wise delta by ts. If these two slopes are same, that means there is no error. But if this value is greater when compared to this one, slope overload error is there, or if this value is greater when compared to this one, granular noise is there. But here in this question, to avoid the slope overload error, that means here in this case you can consider delta by ts should be greater than or equal to, that's all. Okay, right. So here, since you are having either sine signal or cos signal, you can consider am sin 2 pi fmt or am cos 2 pi fmt, generalized case I am talking. Okay, that whatever dm of t by dt you are getting, you can consider modulus or magnitude wise you can consider. Okay, so here you will be getting delta into 1 by ts we can write as fs, okay, should be greater than or equal to, here for ease understanding, m of t I am considering like this. For this question you are having am sin 2 pi fmt right. Just perform the differentiation. You will be getting dm of t by dt. You are getting am into sin 2 pi fmt derivative. You will be getting cos and then 2 pi fmt derivative. You are getting 2 pi fm. Okay. 2 pi fm. Okay, so here just you can mention dm of t by dt max. Okay, so from here I am considering dm of t by dt max, that is am into 2 pi fm. Because for cos or sine, maximal you are getting 1, or if you are putting modulus, from there also you are getting same. Okay, so here you can consider am 2 pi fm. Now here fs given as, okay, from here just I am rearranging. So delta into fs given as what? 3 times Nyquist rate. 3 into 2 fm. That value should be greater than or equal to am 2 pi fm. From here fm will get cancelled and 2 also will get cancelled, right. So just rearrange this equation. So from here we can write am is less than or equal to, just very simple. I am keeping am this side, that means this side quantity is greater, right. So that means am will be less than or equal to 3 delta divided by pi. 3 delta divided by pi, right. Now you can substitute the here data. So am value, here maximum amplitude, that means here in this case what is your observation? The peak amplitude of the message signal should be less than or equal to this much. That means maximum value of am in this question, it will be what? 3 times delta by pi, that's all. 3 times delta by pi. Okay, now in this equation substitute the given data, that's all. am max equal to 3 delta by pi. So here in this case, delta value given as 250 millivolt. 250 milli. Milli we can write as 10 power minus 3, or here already you are having choices in the order of milli, so you can keep in the order of milli only. No need to do the conversion. Just do the simplification of this one and you can mention your answer in the chart. Yeah, Nobita, you can verify here. Whatever the answer you got, that is correct only. Yeah, sorry. Here in this case, yeah. So Nyquist rate for a signal having the bandwidth 3K, sorry. Yeah, 1 second, I am just representing once again. Yeah, in this question, delta value given as 250 milli, and Fs in this question given 3 times Nyquist rate of the signal which is having the bandwidth 3K, correct? Yeah, very good, Nobita. Here it is 2 into 3K, correct? Okay, now this value should be greater than or equal to Am into 2 pi into Fm. Here with respect to this particular signal 1 kHz. Yeah, in this question you are having the twist. This particular signal frequency is 1K. Here the sampling rate they have determined in terms of some other signal. Okay, right. Now you can do the calculations. Okay. So here 1K will get cancelled, 2 is getting cancelled. Okay, you can do the rearrangement. From here you are getting Am max amplitude of the message signal, that is Am. From here you will be getting 3 3s are 9 into 250 milli divided by pi. Yeah, now you can do the simplification. You will be getting 716.2. Sorry, 716.2 millivolt. All of you just verify now. Are you able to get same answer or not? Yeah, Akanksha just verify. Akanksha, Ricky, Nobita, you can verify now whether it is matching or not. Since in this question I have asked that you can round off your answer to the 1 decimal place, accordingly after the decimal point you can round off. Yes, this is right. Very good. See, generally in any of the question you will be having with respect to Nyquist rate or sampling rate when they are defining, and whatever the message signal you are having, in both the cases same frequency only. But in this question twist is there. Okay, instead of directly giving the sampling frequency in terms of this particular message signal, they have given some other signal. Okay, but whatever earlier derivation we got, that one is applicable if they have defined with respect to the message signal with respect to message signal frequency, if they have defined, then that formula will be valid. Okay, right. Yeah, next question, all of you give it, right? So up to now we have discussed the questions related to 5th chapter. 4th chapter and 5th chapter we have covered. Now this is we are discussing the questions related to 6th chapter, digital communication, band pass data transmission. Yeah, for solving this question, okay, regarding here this question is regarding IISc. Regarding IISc, you are supposed to calculate probability of error. See, regarding IISc, FSK or PSK, any modulation technique with respect to digital communication, band pass data transmission, the probability of error you will be getting in terms of Q function. Okay, so regarding IISc, probability of error, regarding IISc, probability of error, the formula is this one, Q of square root of EV by 2N0, square root of EV by 2N0. See, it is very simple, somewhere you can note down, okay, somewhere you can note down. See, like here IISc case you are getting EV by 2N0, okay, if it is for PSK you will be getting 2 EV by N0, okay, if it is for FSK it will be root EV by N0 like this, okay. You can refer our quick revision session, from there you will be getting the formulas. So in that manner you can consider simple logic. So for IISc you are getting like 1 by 2 you can write it as 0.5, and FSK you are getting 1 time, and PSK you are getting 2 times, just like geometric progression, in that manner you can remember. Okay, now coming to energy per bit, okay, so energy per bit is nothing but power multiplied with time, that's all. Okay, whenever you are having cos signal or sin signal, power is nothing but AC square by 2, AC square by 2, and this power we have to multiply with bit duration, that is nothing but T. So in this way, based on the given data, we can rearrange into any other form. Okay, the basic formula is this one. From there we can rearrange into any format. Okay, right. Yeah, no issue, Nobita. So regarding this particular chapter, whatever the formulas required, that you can watch from revision session series, that revision session video, that link is there in the yesterday comment section, yesterday video comment section. Right. Now, from here we can rearrange further. Q of square root of AC square here you should not do silly mistake. These two are getting cancelled. No. Here 2, both are in the denominator only. So you can multiply. So you are getting AC square divided by 4 N naught, and here TB you are having, okay. Regarding RB we have mentioned 1 by TB, so that means TB we can write as 1 by RB, right? I hope all of you are getting the clarity. Because in this question you are having what? Bit rate you are having, so directly you can substitute here. Now just observe here in this question, the probability of error given as Q of 10. The probability of error you are having Q of 10. That means whatever here internal term you are having, that entire internal term we have to equate to 10. That's all. So here root AC square divided by 4 times N naught into RB is equal to 10. You can perform on squaring on both sides. So you will be getting AC square divided by 4 N naught RB is equal to 100. Now read the question so that you will be getting what they have given the data and what we are supposed to calculate. Okay. So here in this question, the amplitude of carrier, that means AC we have to calculate, right? So this equation you can rearrange. AC square equal to 400 N naught RB. Okay, from here we have to find out AC, that's all. Okay. Now here you are having data rate, bit rate, all are one and the same. Here you are having 400 bits per second, that means RB given. Now double-sided power spectral density. See, whenever in the question double-sided power spectral density you are having, okay, that means N naught by 2 they have given, N naught by 2. Suppose if it is single side power spectral density, that means N naught, that's all. Okay, right. So just for reference here I am mentioning, like okay, I am mentioning here N naught by 2 given as 10 power minus 11. Okay, so that means N naught equal to 2 into 10 power minus 11. Units are watt per Hz. Okay, right. Now this N naught you can substitute here, and similarly RB you can substitute here, that's all. AC square equal to 400, N naught we are getting 2 into 10 power minus 11. Now RB given as 400. From here you can do simplification, you will be getting AC equal to under root 400 square, that means 400 you are getting, then here 10 power minus 11 you can add as 10 power minus 10 into 10 power minus 1. So under root 10 power minus 10 is nothing but 10 power minus 5, and then you are having root 0.2. Okay, just to do the simplification of this one and tell me what is the answer you are getting. So here 100 into 10 power minus 3, 10 power minus 5 we can write as milli. So 4 into root 0.2 milli. 4 into root 0.2 millivolt. So just do the simplification of this one and tell me what is the value you are getting. All of you give it a try. It is very simple. If you want, you can use Calci or mobile. Yes, very good, Nobita. Very good. 1.78 millivolt you are getting. 1.78 millivolt you are getting. But in this question, I have asked that you can round off to 1 decimal place. Okay, since in the question if they mention like this 1 decimal place, accordingly we can round off. So from here we are getting 1.8 millivolt. So in this way, whenever in the GATE exam, if they clearly specify, especially for NIT question, up to how many decimal places you have to consider, accordingly you have to follow. Okay. Definitely for the NIT questions, you will be they will give range of numbers. In that range of numbers, if your answer fall, definitely they will be given the marks assigned for that question. Okay. But you should take care. If they don't specify how many decimal places we have to consider, so just for safety you can consider after the radix point or decimal point, you can consider 3 digits. Okay. In whichever cases you are getting more than 3 digits, for those numbers you can round off to 3 decimal places. All of you confirm regarding this question, is it clear for everyone or not? Yes, I hope it is clear for everyone. Right. Next question, it is a direct question, theoretical question. All of you give it a try. Yes, very good, Nobita, very good. Yeah, here we are having quadrature carrier multiplexing. See, in the first chapter, we are having frequency division multiplexing. In order to transmit multiple signals in the same channel, we have used the concept of frequency based sharing, that is called frequency division multiplexing. Similarly, in the digital communication baseband data transmission, there in the pulse code modulation technique, since we are taking the samples, okay, for every TS second we are taking one sample, okay, of one particular signal. Like that, if you want to transmit multiple signals in the channel, okay, that time we are using the concept of time division multiplexing. In order to transmit multiple signals in the same channel, TDM, time division multiplexing. Like that, here we are having quadrature carrier multiplexing. Actually, this concept belongs to first chapter only, but generally we will be covering this particular topic in this particular chapter. Okay, see here, just observe the term quadrature indicates what? 90 degrees. 90 degrees regarding the carrier signal, like in the first modulated signal and second modulated signal, regarding the carrier signal term, the phase angles are getting differed by 90 degrees. Okay, since the phase angle is getting differed by 90 degrees, that means here you are having two carrier signals, the frequency wise both are same, but phase angle wise difference is 90 degrees. Okay, now with the help of just by considering 90 degrees phase shift regarding the carrier signals, now we can transmit two message signals. Okay, so that means in this channel we are able to transmit more than one signal, that means it is a multiplexing, that's all. Okay, since we are doing here multiplexing concept based on the with respect to phase angle, so accordingly quadrature carrier multiplexing. It is very simple. Here whatever you are getting at the output, you are getting like two DSBSC signal. Okay, in both the DSBSC signal, the carrier frequency is same, but message signals can be different. Okay, but the carrier signal frequencies in these two modulated signals are getting differed by 90 degrees. Whatever the modulation technique that you have studied in the first chapter, all you can consider the part of the AM. That is the reason here another name of this one is nothing but quadrature amplitude modulation. Just for your reference, with the help of quadrature carrier multiplexing, you are getting two DSBSC signals, and in both the DSBSC signals, the carrier signals are getting differed by 90 degrees. Okay, right. Next question, this is the question regarding binary FSK, or in short FSK. And of course this question is based on the previous chapter and this chapter together as well. Yes, read the question first. Here you are having voice signal which is sampled at 8000 samples per second. That means sampling rate they have given fs 8000 samples per second. Each sample is encoded into 8 bits. That means number of bits they have given, number of bits per sample, that is n, 8, okay, using PCM. Now with the help of these two we can get bit rate RB, right? Okay, PCM signal is transmitted into free space after the modulation. The bandwidth of modulated signal will be dash megahertz if the modulator used as binary FSK. See, with respect to binary FSK, okay, before discussing this one, just I am giving a hint. With respect to AM signal or DSPS signal, the bandwidth you are getting 2 times maximum frequency of the message signal, 2 times FM, right? So that FM is nothing but what? The reciprocal of time period of the message signal, right? Reciprocal of time period of the message signal. Yeah, Nobita, you are almost closer to the answer, just you have to cross check. Okay, right. Now, with respect to ASK or PSK, the bandwidth you are getting 2 times RB. See, it is just like 2 times FM. But here RB is nothing but 1 by TB, bit interval, that's all. But coming to the FSK, so here bandwidth you are getting for FSK, see, with respect to when you are transmitting bit value 1, you are having one frequency. When you are transmitting bit value 0, another frequency you are having. So difference of those two. So here I am putting modulus. The reason is, in some question they will be considering the notation exactly like this, but in some question they can give ulta. Okay, that is the reason definitely bandwidth should be positive. So you can consider difference of those two. And in addition to that, whatever I have discussed with respect to PSK or ASK, according to that bandwidth you can consider. That means 2 by TB or 2 times RB, your wish. Okay, 2 by TB or 2 times RB. In any format you can remember. Okay, right. Now, here now you can substitute, that's all. F1 is 6 mega minus F0 is 4 mega, right. Then 2 times RB. Here RB is nothing what? N into Fs, with respect to PCM. With respect to PCM, n into Fs. Okay, n value is, okay, just for reference I am mentioning n into Fs. So 6 minus 4, that is 2 mega, right? Then 2 into here n value you are having 8 into Fs you are having 8,000. So here how much you are getting? 8 8s are 64 into 2, 128, right? 128,000 you are getting. So 2 mega plus 128k. So now since you are having final answer in the order of megahertz, better you can convert this one in terms of megahertz. That's all. Yeah, Nobita and Akanksha, just cross check why you are getting here different number. If you are having any confusion or doubt, you can mention in the chart. You might have considered this much, right? 8 8s are 64k, but here 2 also is there, no? You have to consider 2 into 64 is 128. Okay, so from here you are getting 2 mega plus 0.128 mega. So that means you are getting 2.128 mega. So the final answer for this question is 2.128. No, Akanksha. In the formula you will be getting 2 times RB. See, it is very simple, just to correlate. AM bandwidth is 2 FM, DSBSC bandwidth is 2 FM. Similarly, with respect to ASK and PSK, you are getting 2 times bit rate. That bit rate is nothing but 1 by TB. Okay, but here in this question, bit interval not given, but regarding that bit rate, you are getting the clue from the PCM, like that. Yes, Nobita, it is plus 2. See, it is very simple, just for your understanding. Like when you are having one rectangular function, if you apply Fourier transform, you will be getting sinc function. And that rectangular function is having the low frequency, that is the message signal. Definitely that sinc function, you are getting low frequency, or in other words, we can say it is centered around 0. In the sinc function, you are getting one main lobe. After that, infinite side lobes are going towards positive frequency axis and towards negative frequency axis. And I hope all of you know that regarding sinc function, 99% of the energy you are getting in the main lobe. That means all other side lobes we can ignore if you are passing that signal through band pass filter. Okay, I hope. Okay, so that means we are considering only main lobe. That main lobe exists from where to where? Minus 1 by TB to plus 1 by TB. All of you are agreeing or not? Akanksha and Nobita. Regarding sinc function, when you are considering the rectangular pulse, the other side lobes I have ignored. I have considered only the main lobe. Main lobe, like say for example, rectangular pulse duration you are having TB. For that, here like first 0 crossover frequency, that time in that frequency you are getting 1 by TB. Here this side minus 1 by TB. Is it clear? Up to this point. Yes, clear. Now, when you are using band pass data transmission, that means you are transmitting the message signal with high frequency carrier. That means here in this case, we are multiplying with AC cos 2 FCT. So, in the introduction of modulation concept only, you might have got to know, whenever you are multiplying any any signal with high frequency, definitely what will happen? The shifting operation is happening in terms of frequency. That is the reason that property is called modulation property. So whatever the main lobe you got, that is centered around 0, after you are multiplying with high frequency carrier signal, this entire spectrum, now it is shifting around FC. So that means upper frequency you are getting FC plus 1 by TB. Just for reference I am mentioning, I am not drawing the complete graph, but I am just giving the hint. Say for example here, with respect to original signal, you are having like 0, and here 1 by TB, and here you are having minus 1 by TB. With respect to frequency axis. Right, this is your with respect to message signal. Right, now after you have multiplied with high frequency signal, now the entire spectrum came where? Say for example, this is 0 frequency. Now it is centered around FC. That means if this is FC, This one will be what? Fc plus 1 by Tb. And this one will be Fc minus 1 by Tb. Yeah, Akanksha and Nobita, confirm up to this point, is it clear or not? This is regarding your rectangular pulse, time domain, corresponding frequency domain, sinc function. I am not drawing the complete spectrum, but just I am focusing with respect to frequency axis. Okay. So with respect to frequency axis, here the signal is centered around 0, whereas here centered around Fc. Now, yesterday also we have discussed regarding the bandwidth. Regarding the bandwidth, we have to focus only on the positive frequency axis where the signal exists. The difference of maximum frequency and minimum frequency, that's all. Now bandwidth is nothing but the difference of these two. Now what you are getting? See, Fc plus 1 by Tb minus of Fc minus 1 by Tb. That means Fc is getting cancelled, 2 by Tb you are getting. That itself is the bandwidth with respect to your ASK or PSK. Okay, that 1 by Tb is nothing but Rb. 1 by Tb is nothing but Rb. See, with respect to this signal, bandwidth means 1 by Tb. I am agreeing. With respect to message signal, bandwidth means 1 by Tb, that is nothing but Rb. But with respect to modulated signal, bandwidth means 2 times, because the entire spectrum you are getting on the positive frequency axis. Okay, right. Yeah, no issue at all. Whatever the doubts you are having, like this, you can mention in the chart. I will be clarifying, because the basics wise, if you are clear, then definitely you can answer any question. The level of the question, let it be. No problem. You will be in a position to attempt. Yeah, regarding that, see, regarding whatever the binary data you are having, in order to represent, we are having different types of signaling. Say for example, in order to represent, like say for example bit value 1, we can use 5 volt. In order to represent bit value 0, 0 volt. So that means what? It is like on off signaling. That is one representation. There, for in order to represent, in order to get the standard equation simpler format, instead of 5 volt, we are considering like 1 volt. Okay, for bit value 1, 1 volt, bit value 0 means 0 volt. Either bit value 1 or bit value 0, we are representing one complete bit interval, TV duration. Okay, now, so that particular signal we are calling as on off signaling. Similarly, we are having for PSK or FSK, that signaling we are not using, because there is a drawback. Okay, because with respect to PSK, if you use on off signaling, you will be getting both are having same phase, but we have to differentiate. If one symbol you are having 0 degree, other symbol should have 180. Similarly, vice versa. That is the reason we are using NRZ signaling. NRZ signaling means what? Bit value 1 we are representing plus 1 volt, bit value 0 as minus 1 volt. So that means you are getting rectangular pulse on the positive amplitude axis, or rectangular pulse you might be getting with respect to negative amplitude axis. That means you might be getting the sinc function like this, or you might be getting sinc function like this. But at any point of time, either you might be transmitting 1 or you might be transmitting 0, not both at the same, right? So that is the reason here magnitude wise we are drawing the spectrum, so accordingly you can consider the bandwidth. Okay, I hope it is clear, Nobita. Yes, with this understanding, all of you give it right. This is a simple question. Regarding BPSK. Yeah, your question is you are making unnecessarily complicated. It is very simple. Here, whatever the question, whatever the chapters we are discussing, those are related digital communication. Okay, here the signal present in the form of digital. That means binary. Okay, you can represent on-off signaling, or you can represent NRZ signaling, non-return to 0. So that means you are getting the pattern. If you observe, you are getting like rectangular pulse. One particular bit interval when you are observing either positive amplitude axis or negative amplitude. But if you are using that one, sync pulse, okay, then you can apply duality property from your signal and system. See, for rectangular pulse, Fourier transform is what? Sinc function. Similarly, for sinc function in the time domain, if you apply Fourier transform, for rectangular function you are getting duality. That means you will be getting rectangular function if you are considering even function exactly similar, but only thing original function you are having time domain, here you are getting frequency domain, like that. Yes, very good Akanksha and Nobita, right. So here the question is regarding BPSK, right. So here probability of error is minimum. Yes, this is correct. With respect to BPSK, among all the cases, ASK, PSK and FSK, in PSK probability of error is minimum. Okay, and coming to the bandwidth, here I already mentioned with respect to ASK and PSK bandwidth is same, that is 2 times RP, whereas with respect to FSK we got this much. That means among all the cases definitely in ASK and PSK bandwidth is minimum, but here the context of the question is with respect to PSK definitely bandwidth is less. Okay, next, it is best when compared to, yes, it is best when compared to these two. So all the above are correct. Okay, so this question choose the correct option, so that means option D. Okay, since the question is MCQ, option D is the correct answer. Yeah, next question. So till now we have discussed the questions related to 6th chapter. Now these are the questions related to last chapter of communication. This is a very interesting question. All of you give it a try. I am giving 2 minutes time. At least you can give it a try for one case. Okay, here you are having 2 cases. Okay, at least if you are getting so much time for the second, I will give the hint. Okay, what formula you have to use. At least you can give a try for the first. That is easy. After that, you can give a try for second. Yeah, as of now, the statement 1 is correct. Regarding in order to decide statement 2, if you know one standard formula regarding especially infinite series, then only you can solve this question. Otherwise, you cannot solve this question. That is the reason, like at least with the help of this question, you are getting to know whatever the infinite series expansion you are having in your mathematics, at least focus on some of the standard equations, so that while solving communication system subject, some questions you are getting in the GATE exam based on that as well. Okay. So here it is very simple. Like you can observe here, the question is very simple. Regarding entropy, you should get 2 bits per symbol. Entropy means on an average for every symbol how many bits we are representing. Okay. So the formula is very simple. The probability multiply with log 1 by probability, because log 1 by probability is information, and for that symbol in order to occur, how much probability is there. Like that you have to add for every symbol. That is the entropy. Now in case 1, you are having 4 symbols and each one is having equal probability. That means every symbol in order to occur, the probability is 1 by 4, because sum of all the probabilities is equal to 1. That's all. Okay. Now with that understanding, for every symbol probability is 1 by 4. Now entropy formula is this one, probability into log 1 by probability. Like that you have to add for every symbol. Okay. So it is very simple. Whatever the term here you are getting, like the term you are getting 4 times, multiply the term with 4. So here 4 is getting cancelled. Log 4 base 2 is 2. See, with respect to information theory concept, whenever regarding the information you are using the logarithm symbol, here base value is 2, because here we are determining for binary data, right? But whenever SNR calculations you are using, that time logarithm base value is 10. Okay, this one important point you people can make a note. Okay, now here you are having 2 bits per symbol. Yes, that is correct. Now coming to the second case, you are having infinite symbols. The series is going like this regarding the probability 1 by 2, 1 by 4, 1 by 8, 1 by 16, like that expansion is going on. Okay, now use once again same formula, substitute, and here in this case 1 by 2 you can take common from all the terms. You are getting like this function. Okay, now this is the important point. Okay, this formula you might have aware, but now you might have forgot, no issue. But like this, whatever infinite series expansion formulas you are having, you can just Google or you can refer your maths. Okay, and you can note down all that important points regarding formulas regarding infinite series expansion. Okay, 1 plus 2x plus 3x square, like that, like this expansion. After doing the simplification, you are getting like this 1 minus x whole power minus 2. Here x is nothing but 1 by 2. 1 minus half is 1 by 2, that you can write as 2 power minus 1 whole power minus 2, that is nothing but 2. Okay, so 2 square is nothing but 4, 4 divided by 2. Yes, once again we are getting 2 bits per symbol. Okay, but suppose, sir, even though we have learned, but somehow in the exam we are forgetting these kind of formulas. No issue. At least in that case, what you can do, like this question if you are getting in the GATE exam, you may not attempt these kind of questions in the first round, but in the second round means in the second 1.5 hour, if you are getting like some time, if you want to solve these kind of questions, what you can do, say for example, whatever like here in this expansion, like 1, 2, 3, 4 terms you are having, so you can add these 4 terms and how much you are getting, just observe, and that one you can approximate, like that you can decide. Say for example, here 1 by 2 is how much, 0.5, here 2 by 4, once again 1 by 2, that means 0.5. So with the help of first 2 terms you are getting 1. Okay, after that just add these 2. Okay, whether you are getting 1.5 or 1.8, something like that, based on that you can guess, because even the series is expanding, but even like whatever higher order terms you are getting, that values are going to be very small. So majority of the answer, I mean to say, if you are able to consider 1, 2, 3, 4, you can consider fifth term. That much you can consider. From there you can guess, that's all. Okay, accordingly you can choose approximate, like that. Okay, right. Yeah, next question, all of you give it, right? So this is one more question, like here whenever in the question they specify raised cosine spectrum or raised cosine pulse, or when you are having the data like roll-off factor. Okay, in this question they not mentioned, but here 75% excess bandwidth. Okay, that 75% indicates roll-off factor. Okay, whenever you are getting the formula like this, that time regarding the bandwidth formula you are having, the standard format you are having RB by 2, sorry, RB into 1 plus alpha divided by log m base 2. Okay, I am just giving the hint regarding the bandwidth formula. When you are having the raised cosine spectrum, RB into 1 plus alpha divided by log m base 2. This is the formula whenever raised cosine spectrum is given or roll-off factor mentioned, that time. But here regarding alpha roll-off factor, whatever in the question if they specify in terms of percentage, just convert into the normal. So here in this question already bandwidth they have given 25 kHz, 25K. Yeah, Here, read the question. Here RB is nothing but n into Fs. Yeah, RB equal to n into Fs. Sorry. Into 1 plus alpha is 75%, that we can write it as 0.75 divided by log m base 2. So from here we have to calculate m value. So here, just for understanding, I am giving the hint. I am not solving the question completely, but I am giving all the hint points. You can substitute and tell me final answer. So here you are having number of levels as 64. So L equal to 64. So this is nothing but 2 power n. From here we are getting n value as 6. 2 power 6 is nothing but 64, right? Okay, next, here you are having sinc square function, okay. Yeah, so just observe here, whatever internal term you are having, okay. So from there you are getting the frequency. So whatever sinc square term you are having, okay, just for reference I am mentioning here. Yeah, here you are having sinc square. Sinc square you can write it as sinc square function. Okay, you can write it as sinc x into sinc x. Okay, so that means you are performing what? Multiplication. Here you are performing multiplication in the time domain. That means equivalent in frequency domain is what? Convolution. That is a hint point. When you are having sinc function, for that, say for example, rectangular pulse Fourier transform is sinc. For sinc function, inverse Fourier transform. Okay, sinc function in time domain, that means rectangular pulse only you are getting in the frequency domain, like that, vice versa. Okay, so with that understanding, so for sinc function you are getting rectangular pulse. Okay, with that understanding, just give a try. What is your FM for this particular question? Okay, just for reference, here I am mentioning, suppose you are having A into rectangle T by T. Fourier transform you will be getting AT sinc FT. AT sinc FT. So here it is a function of time, small t, whereas here you are getting function of frequency. Okay, but here you are having function of time. Okay, so this function you are having here, AT sinc here TT, because it is the time domain, right? Okay, now for this Fourier transform, by using dual property, you are getting A into rectangular. Here it is a function of time, now you are getting frequency, but here it is in place of t, you can keep minus f divided by 2. Since the rectangular function here we are considering even, okay, just like sinc function is a even, correct? So now you can represent this one as A into rectangular function of f by t. A into rectangular function of f by t. That's all. Okay. So just you focus here. For this particular equation, the Fourier transform is this one, right? Now here you are having like this function 2 times multiplication. Okay. When you are doing multiplication in the time domain, so that is what you have to do convolution in the frequency domain. Okay. So from this understanding, you can observe here, like here, like whatever the term, okay, just observe here regarding sinc square term. Okay. So that one you can write like sinc tt into sinc dt. So that means with this understanding, here whatever 10 power 4 you are having, that is nothing but capital T. Okay, with this understanding you are getting capital T equal to 10 power 4. Okay, from here f value you are getting 1 by T. Okay, so that means 1 by 10 power 4. Okay, just 1 second. Yeah, from here we are getting T value as 10 power 4. So now here what is your understanding? You are having one rectangular pulse that is having the duration. From here understanding is, just for reference here I am mentioning like this. You are having one rectangular pulse, that duration you are getting like this 10 power 4. Okay. Yeah. See, this entire duration is 10 power 4. Right. So this is centered around 0. Now can you tell this one? I hope all of you are able to get. See, here whatever the capital T you are having, that same thing here, frequency. I hope all of you got the clarity. Now with this understanding, this value will be what? 10 power 4 divided by 2. Similarly here, minus 10 power 4 divided by 2, correct? Minus 10 power 4 divided by 2. Now tell me, when you are performing convolution operation on the frequency domain and you are having 2 equal duration rectangular pulses, you will be getting triangular signal, and regarding that particular triangular signal, you will be getting here whatever the duration here you are having, that is getting doubled. Okay, like that you can consider minus 10 power 4 divided by 2, multiply with 2. So that means here you are getting minus 10 power 4, whereas here you are getting plus 10 power 4. So this is the spectrum regarding your what? M of t Fourier transform. Is it clear for everyone up to this point? So for this question you are getting Fm equal to 10 power 4 H, that is nothing but 10 kilohertz. See, for solving this question, you should have the knowledge of signal system. Once if you are having the knowledge, definitely you can solve this question. Is it clear or not? All of you confirm up to this point. Nobita, Akanksha, everyone, please confirm. A into rectangle T by T. With respect to time domain, whatever the duration you are having, that you are getting in terms of frequency 1 by T, that is nothing but F, correct? Right, like that. Yes, very good. Now that Fm you got, now according to this question, Fs yeah, here in this question we haven't specified anything regarding sampling frequency. If in the question if not given, then that time you can consider Nyquist rate. You can consider. Okay. So here Fs equal to 2 times Fm, because this is the minimum sampling rate that you can consider. So that means you are getting 20 kilohertz or 20k samples per second. Right. Then here n value we already got. Now all the values you can substitute in this particular equation and do the simplification. So after that you will be getting m value. All of you give it try. Whatever n value we got, fs value we got, and this expression, do the simplification. From there log m base 2. Okay, all of you just give it a try. From equation 1 regarding log m base 2, after doing the simplification, how much you are getting, tell me. And from there you can figure out m value. Log m base 2. I hope all of you will be getting 9. You can just cross verify. M equal to 2 power 9, that is nothing but 512. So this is the final answer for this question. Yeah, no issue, Nobita, no issue. Okay, I hope it is clear for everyone. If any of you are getting different answer, you can mention in the chart now. Okay, next question. This is an easy question only. I hope all of you can give it a try. Choose the correct option or options regarding the channel capacity of Gaussian channel. Okay, so with respect to information theory concept regarding the bandwidth, you are having one standard formula like channel capacity equal to B into log 1 plus s by n base 2. Log 1 plus s by n base 2. Okay, here signal to noise ratio, we have to, while substituting, we are considering normal values. Okay, right. So read the question here, option by option. It becomes double if the signal power and channel bandwidth both are double. Okay, case 1 I am considering. Case 1. Regarding the channel capacity. Channel capacity means C. So in case 1, signal power, channel bandwidth both are double. Okay, signal power is doubled. So that means S become 2 times S and bandwidth become 2 times P. Now you can substitute here. Directly I am writing here, in place of B you can put 2B, then log 1 plus, in place of S 2 times S, and then and one more important point. Okay, just I am mentioning here only. So from here I am writing B log 1 plus S by, here N is the noise power, right? So when you are having noise power spectral density N naught, okay, when you are having noise power spectral density N naught, that one you can multiply with the bandwidth. From there we already discussed noise power spectral density units are watts per hertz. You are multiplying with the hertz. That means hertz is getting cancelled. From there you are getting the noise power. Okay. Now in this equation we can substitute 2s divided by n naught as it is, and then 2b. Right. Here 2 is getting cancelled. Right. So now if you observe b log 1 plus s by bn naught, so that means here you are getting 2 times earlier channel capacity. Say for example this is C dash. Now you are getting 2 times C. That means whatever earlier channel capacity you are having, if you are making signal power double and bandwidth double, then resultant channel capacity becoming double. So that means now, yes, option A is correct. It becomes double if the signal power and channel bandwidth both are double. Now with this understanding, so directly we can eliminate this one. Option B we can eliminate. Now among C and D we have to verify. Since I have discussed one case, now all of you can give it a try. If you are making signal power and channel bandwidth both are half, then what is going to happen regarding channel capacity? All of you give it a try. Among C and D, which option we can choose? Yes, very good, Nobita, very good. So just very simple. Here only I am writing case 2 also. Case 2, signal power become half bandwidth, signal bandwidth also become half. So it is very simple. In this term, whatever signal power S by 2, here bandwidth B by 2, that 2 is getting cancelled. Okay, here what happened? B by 2 you are getting. That means whatever earlier channel capacity you are having, that is becoming half. So C dash equal to C by 2. Directly I am writing. You can visualize from the previous equation, right? So C by 2, it becomes half if the signal power and channel bandwidth both are half. See, while solving this question, only one particular hint point is you should have the knowledge regarding this one. That's all. In general, noise power you know, but the noise power you are getting from power spectral density as power spectral density multiply with bandwidth. Okay, right, that's all. Yeah, next question, and this is the last question regarding communication system subject. So this is the question related to CRC, cyclic redundancy code. Okay, so here you are having the message signal bits, and regarding the CRC code, divisor polynomial has given. Now regarding the transmitted bit sequence, the question. Okay, so for solving this question, it is very simple. Whatever here you are having like one polynomial, that you can represent in the standard format, that's all. Like 1 into x power 4 plus 1 into x cube plus 0 into x square plus 0 into x power 1 plus 1 into x power 0. So that means whatever the polynomial has given, that you represent in powers of x, and whatever the powers here you are having, the corresponding coefficients are 1, whichever powers are missing, corresponding coefficients are 0. Okay, so from here you are getting to know the given polynomial is having 5 bits. Okay, the given polynomial is having 5 bits. Okay, right. Now here what we have to do, whatever the message signal information you are having, consider, and here since you are having 5 bits, you have to consider minus 1, 5 minus 1, 4. Okay, that 4 bits we have to append while you are transmitting. So that is the reason initially we are considering 4 zeros. Okay, right. Now here just like your normal division operation we are doing, but here in this course we are performing modulo 2 division, or in other words we can say XOR operation. Okay, here quotient is not at all important, here remainder is the important. Okay, right. So here 1 1 0 0 1. Now you can perform XOR operation accordingly you are getting. Next bit you can consider. Now once again copy, perform XOR. Like that, in general you will be considering 1 1 digit, but in this course since you are having 5 bits, accordingly you can check in the next iteration whether you are able to get all the 5 bits or not. If not there, accordingly you can append next sequence bits. Now you can copy and perform XOR. Like that process you can continue, and in the last stage, okay, whatever the last 4 bits you got, here 4 bits we have kept 0. Accordingly in this process, whatever the final 4 bits you are getting, that 4 bits you can append at the last with respect to your message signal, that's all. Okay, so that option is there in here in option D. Yes, option D is the correct answer. Say for example, this is the encoded signal that you have transmitted from the transmitter. Suppose at the receiver, if you got exactly the same signal, and if you perform, okay, this signal you can consider here, and like this modulo 2 division or XOR operation you can perform, there all the bits you will be getting zeros. That means if you are getting all the bits zeros, that means whatever the signal that is transmitted, you are receiving the same. That means there is no error there, okay, in the received signal. But if you are getting other than all the bits 0, if you are getting in terms of ones and zeros, with the help of that you are coming to know in which particular bit position you are getting the error. Okay, see, when you are having 4 bits, you can find out the equivalent value, and from there you can figure out, like with the help of, here totally you are having 5 bits, right? So like that process you can do. With the help of those 5 bits you will come to know in which particular bit error is there, like that. Okay, so this is one method regarding CRC, cyclic redundancy check. Okay, I hope it is clear for everyone, right? So in this particular session and yesterday's session together we have discussed total 40 questions. Yesterday 20 questions we have discussed regarding first 3 chapters of communication system subject. Similarly in this session we have discussed 20 questions regarding last 4 chapters of communication. So all together we have discussed 40 questions, right? So these questions are more than sufficient, but as I mentioned earlier, whoever want more practice regarding communication system subject, whatever the links our team will update in the comment section of this video, you people can practice. Okay, so whoever attended, okay, the live session, I come like all of you performed very well. I have noted all of your names. Okay, but whoever watching this particular session later, so all those students can mention out of 40 questions, yesterday's session and today's session all together, out of 40 questions, how many questions you got correct, you can mention in the chat, and you can share your experience also in the comment section. Okay, right. So just to appreciate the students whoever attended during our live sessions, and of course I have noted whoever performed well for most of the questions. So accordingly, I am putting here the toppers of the communication Gate Score Booster live sessions. Okay, right. Hearty congratulations to all the toppers. I am writing the names now. Nobita, Akansha, Ashini. I am considering with respect to yesterday's session and today's session, both. Hemant, Harshit. Yeah, hearty congratulations to all the toppers. Okay, here all the students whoever attended yesterday's session, today's session, all the students whoever names I have written here all performed equally. Okay, here there is no discrimination. Just I have mentioned like one after another, but all the 5 students have performed equally. Yeah, Akanksha, for previous one it is very simple. Whatever the divisor polynomial you are having, divisor polynomial highest power is how much? 4. Okay, so when you are representing bits like 2 power 0, 2 power 1, 2 square, like that you are getting 2 power 4, so that means 5 bits are there, right? So 5 bits minus 1, what are the number of bits you are having? Minus 1, like that. Okay, so that many bits we have to append along with the message signal. So that is the reason initially we are putting zeros, after that like this process we are doing, and at the last what are the 4 bits we are getting, we are appending, that's all. Okay, I hope it is clear now. Yeah, I hope all of you got maximum benefit from yesterday's session and today's session regarding communication system subject. Okay, so I am discussing some important updates. All of you can share this valuable information with all of your friends and juniors, whoever like preparing GATE exam this year or even upcoming years. Okay, so this is the Telegram channel regarding our IMS GATE Academy. Link is already provided in the description of this particular video. It is free for everyone. Anyone can join, whoever preparing for GATE exam. Okay, so here whatever we are doing upcoming live lectures, all the important updates regarding the schedules you will be getting in our Telegram channel, and you will be getting whatever the class during the class, whatever we have written during the on the digital board during the live class, that particular notes also we are sharing in the PDF form in this particular group, and all these other important updates you are getting. Okay, yeah, so whatever the questions we have discussed in our score booster sessions, all of you got to know the kind of quality questions we have discussed, the number of models we have discussed, and we have discussed whatever expected models for your coming GATE exam. Like this, whoever targeting for GATE 25 exam, since majority of the students at this point of time, whoever can attempt good number of quality questions and good number of tests, definitely you can get very good rank. Okay, that is the reason I am recommending for all the students whoever not enrolled at our IMS Academy for any of the program, for all those students at least you can book for you can enroll for Test Series Plus program. Regarding this particular link, Google form is already provided in the description of this particular video. As of now, the limited time period offer is running regarding 20% regarding Test Series Plus program. You will be getting all these benefits. You will be getting all these benefits. You can maximize your score. And one more important update, whoever currently in second year BTech or third year BTech, and whoever targeting for upcoming GATE exams. For them, I am recommending to enroll for live online program. So you can book the free counseling session. Our counselors will discuss in detail about our program features. Okay. Yes, very good, Nobita. Very good. Correct. Yeah, that is correct. Yeah, that's all regarding communication system GATE score booster questions. So far I have discussed in this GATE 2025 series regarding score booster sessions. I have taught regarding digital circuit subject, regarding network theory subject, and regarding communication. Okay, I hope many of you might have attended. Due to any reason, if you have missed earlier lectures, you can watch. No issue. It will be available in our YouTube channel. So you can just check the playlist name regarding GATE score booster with my name. Okay. So in that playlist, you can find out regarding these three subjects, whatever the sessions I have took. Okay, all of you can do practice in order to maximize your score. Okay, thank you everyone for attending yesterday's session and today's session in the live class. Okay, and I have seen all of your performance. You are able to perform very well. Okay, so keep continuing in the same spirit and try to do revision and try to do practice as much as possible, so that the more you do the revision, the more you do the practice, definitely you can avoid the silly mistakes in the GATE exam, and moreover you are getting the confidence before you are going for GATE exam. Okay, so wish you all the very success in the coming GATE exam. So thank you everyone.